We will be using Newman projections as a way to look down a sigma bond and see how they can rotate. So one of the important things about the sigma bonds is that they do have that free rotation because they are made up of just those hybridized orbitals that are overlapping head to head, so that can actually rotate. And we can actually get different structures if we rotate around the sigma bonds. And that's basically putting the molecule in different shapes. And those shapes are called conformers. And we're going to see some important ones for certain molecules like ethane and butane, for example. And we're going to use the Newman projections in order to view these conformers because it's going to be easier to see what exactly is going on when we're looking down one bond. So to do that and to show Newman projections, we first have to talk about how do we put a molecule from its hash wedge structure into a Newman projection. And we'll start with the probably one of the easier ones, ethane. So for ethane, we only have one carbon-carbon bond, and we're going to look down that one. So it's highlighted. This is the one we're looking down, and we've drawn a little eyeball over here, and this is the direction we're looking. It actually doesn't matter which way you end up looking down the bond. You could look from the right as well, and we'll see that in the example we do next. It really doesn't matter as long as we're looking directly down the bond, and as long as your Newman projection is consistent with the way that you're looking down the bond. So here we're saying we're looking down it from carbon 1 at the front, 2 at the back. How we would represent carbon 1 is we see that if we were looking at it this way, we would see 1H going on the left, 1 hydrogen going up towards the right, and then 1 going straight down. So this is the one that's going up to the left, this one's going up to the right, and then this one is straight down. So this one would correspond to that bolded H, and this one will correspond to the dashed H. This one is the normal line H. And so this is going to be our front atom. We see that in the front, we'll actually see where all the bonds join. And when we go through the video with the model kit, you might be able to see this a little bit easier. If you build it out yourself too, you'll be able to see this a little bit easier, that you're going to be able to see all those lines, and also that this bold one is the one on the right and the hashed one is the one on the left. So that's how our front atom is going to look. What about our back atom? So for Newman projections, the rule is to make the back atom the circle. And so that's how we represent the atom that's behind. And so that's how we show that that atom is actually behind the one in the front, so that is not ambiguous. And so with this circle, this represents atom 2. We have one hydrogen that's going straight up. That's this one here, because we're still looking at it on that side angle. Note that we did not show, and we're not going to show this bond between 1 and 2 because we're looking right down it, so we're not going to see that bond in our Newman projection. But we do have this bond to the H that we'll see straight up. We're going to see this bond that's bolded to the H. That one's going to be on the right-hand side because of the direction that we're looking down the bond. That one's going to be towards our right. And then towards our left is going to be this hashed one, and that's going to be that one there. And so that's how our back atom is going to look. Unlike the front atom, where we joined all the bonds directly to each other, basically, to represent that's where that atom 1 is, or carbon 1. Because carbon 2 is represented as a circle, where the bonds stop, they stop at the circle itself because the circle is representing that atom. And so we don't continue these lines in any farther than the circle. That's one of the common things that we see for whenever people draw the Newman projections incorrectly. That's one of the things we can see is these lines extending in too far. So make sure you're stopping right at the circle. And so if we put these two together, we're looking down the 1-2 bond. We're not showing that bond. We're just showing carbon atom 1 and everything else that's attached to it, and then carbon atom 2 and then what's attached to it. And so we kind of put those two together. So this is for ethane. Let's just see a little bit more complex one. How would we make a Newman projection? So this one is a typical type of question we could have for the Newman projections, and it's asking you to draw the Newman projection down the C4-C5 bond. So the bond we're looking at and the bond we're looking down is that one. If we want to give it a highlight, we can do that. That's the bond we're looking down. What can be useful when drawing the Newman projection out is to actually draw where are those H's that we're not showing. So we see that carbon 4 has two bonds in the plane of the paper, the one bond to carbon 3, the one bond to carbon 5. And so that means that it's going to have a bond going out. This is going to be a bold H. And then we're also going to have an H going back that we're not showing. So normally we would just kind of write them in as normal lines, but now that we're considering how these molecules look in 3D, we definitely want to draw out the hash and wedge because those are where the other two locations of the H's are. Same with carbon 5, so it has that same situation. So we're going to draw the bold H and the dashed H because the two that are in the plane are already shown and they are tetrahedral. And so now we're going to look down the C4, C5 bond. It actually doesn't matter if you look for carbon 4 at the front or carbon 5 at the front. Typically, I'll draw it so if it's 4, 5, I'll look down 4, the lower number. So if you want to kind of draw your little perspective over here, you're going to be looking from that direction. So when we look from that direction, our front atom is going to look like a Y because we're going to have this H up to the left, so that'll be a H. Up to the right, we're going to have another H, so that's going to be an H. And then straight down, we actually have carbon 3, 2, and 1. So we're going to have to show that as well on our front atom. So right now, we're just dealing with the front atom. We said the dashed H was going to be on the left, the bold H is going to be on the right, and then carbon 3 is going to be at the bottom. Carbon 3 is attached to 2 and then 1. So we can draw that zigzag. Alternatively, you could have at the end put CH2, CH2, CH3 and just condensed it. You don't have to continue with the line structure. So that's something you can do if you want. Let's put in some of our carbon numbers just so we don't get lost with this. So we have 3, 2, and 1 down there. And we're going to now look at carbon 5. So carbon 5 is in the back. And we're going to have this one represented as a circle. So let's go ahead and draw that circle that represents carbon 5. So this circle is representing carbon 5. And then we're going to have two H's. So from this direction, the bold H here is actually going to be on this side, on the right-hand side. And the hashed H, because it's going back into the page, that's going to be on the left-hand side. So we can go ahead and draw in these two H's. And if we want, we can put that this is carbon 5, the circle. And then now we have one more bond. So our last bond is going to be the bond that goes to carbon 6, and then carbon 6 is also attached to carbon 7. So let's go ahead and draw carbon 6 and 7, and let's label 6 and 7. Let's also show what you could have drawn this as. So you could also have abbreviated those groups. So let's do that because sometimes people prefer to abbreviate the groups. So we're going to just put our H's in because those are going to look the same. For the carbon 3, you can do CH2, carbon 2, CH2, carbon 1, CH3. So we could have done that. And then at the top, carbon 6 is a CH2 and carbon 7 is a CH3. So let's transfer our numbers in there just so that we know that this other representation could be used. So we still have our 7 total carbons. 4 and 5 are still the ones that are in the actual Newman projection because that's the bond we were looking down. We see that we basically have shown every single bond, especially in this structure. We drew out every bond except for the 4 or 5 bond explicitly because we are looking directly down it. So we're not showing that. But you could draw this molecule as either the one on the left or the Newman projection on the right. As long as the right number of carbons are there, that's what we're looking for. It also really helps to number your carbons. So when you're doing it yourself, make sure that you're getting the correct number of carbons by numbering them in here, tracing them on here, where exactly do they end up, or on this structure, if you wanted to condense them, you still need to make sure that you have the right number of carbons.